Yeah, so we are live. I can.
Yes. Hi, Aditya.
So, how you doing?
Yeah, I'm doing great. Are you taking my interview or we are here to read some
So we'll be
paper?
again. We are back again with another paper. This white paper reading session, and maybe before this white paper reading session, I'd like to. I was having this idea. I was having this idea this yesterday or day before that. Like maybe we can start a series in parallel to this, where we'll be like taking up any computer science or any physics or any topic in general, and we will try to explain it in 5 levels, like explain it to kids, then high school, then college, and then experience, and then expert.
Sure,
So
sure.
what will how will that help? It will like increase our
Understanding.
understanding of that topic as well, and how we are like communicating our understanding to someone else.
Right, right.
So
Good point.
basically, yeah, so it will affect positively our explanatory skills, like how we are presenting our thoughts, maybe
Yes.
that have some different repercussions
Okay.
on the positive side. So that's that. Mm. So do you want me to like share my screen for this paper, or
Yes, you can share your screen.
okay.
Yep. So if you have Edge browser, you can open it on the Edge as well. You can open in the Edge as well to mark the important pointers as well, right?
H.
So I think Google Chrome should also take care of the PDF thing like Edge does. It will be great.
So my screen is visible, right?
Yes, it's visible.
Like okay, cool. Let me go the highlighter.
So, what was your understanding and the need, or what problem exactly this paper solves? Can you talk about that a little bit?
Yeah. So basically, this papers highlights like how if some user is purchasing some item, so how the relative items that might have some other users with same interest have encountered or like ordered from the Amazon, and that should be recommended to that user, like the user who is buying. So basically in the Amazon app or in the website, like you can see after like we scroll through the buying options of a product, where at the bottom end we get few other products that might have like that might have been ordered by the person with same interest as that of yours, and things similar to that. So how we are like finding that similar items, this paper discuss more on that.
Okay.
So there's math involved, and mostly like the vector databases and like this machine learning in general. Not machine learning, but like how a very huge cluster of objects are related. So I can recall like have you followed Gaurav Sen recently? So he has shared a vector database problem, like how basically how LinkedIn manages, like LinkedIn shows first connection, second some first level of connection or like second level of connection, something like that.
The
So how
verbose, we can say in different things you might have said verbose. So suppose you are using Nmap, it's verbose or depth. It's called depth, I guess. So if you are using Nmap, then you can crawl to the websites to the second level, third depth, fourth depth. So that depends on the parameter which we give. So are you talking about that only?
mm, I'm not sure, not that one.
On
Depth
the on
crawling
the
maybe.
connection level, are you saying, right?
Yeah, I'm
So
saying
suppose,
how like the Facebook suggests friends, right? In the
right.
similar fashion, LinkedIn suggests these people. and they say like they mark the people to be like third level connection, second level connection. So second level basically my followers might follow them, so that's second.
Right.
My followers might follow that person, so that's third level. So how am I going to get suggested that third or second level people? So that is also somewhat similar to whatever we are going to discuss in this paper, like the recommendation part.
Okay.
So the reference to Gaurav Singh's video was that like he actually simply oversimplified the stuff. Like instead of like finding these running these expensive algorithms to get the matches, he like quantified that problem to he solved that problem using what we call set you what it's called set intersection. Yeah, so basically we you have two sets and then you have to just find the intersection. So but the data within that sets is obviously going to be used from the vector databases. So no problem, so let's get started with the paper. So how do you want us to go it, like shall we read it or
I think like we can first, read through the what are the previous methods which is available to solve this problem, and then I think it would be great if we'll discuss directly what is the method which Amazon is trying to do. Otherwise, it's redundant to talk about all those stuffs. So uh, I think we can directly jump to the item to item filtering which Amazon is using, and this traditional collaborative filtering which they have talked about, that they were mapping user to product and then they were trying to like it could be solved by that as well.
Mhm.
So suppose Aditya is buying the same stuff, Akhil is buying the same stuff, then uh, s- storing them and then trying to find the matches between those two. So that is very costly on the user level and the product level both.
Yeah.
So they have, I think, like thought of why not do on the product level only, so that this will solve few more problems. So suppose you are landing in the amazon.com for the first time, then you have no history, right? You have no data. But
Yes.
and even then they have recommendations, as you can see.
Yeah.
That is
Absolutely.
only due to the product based recommendation thing that they have come came up with. So yeah, so they have made it. I think somewhere I have read that they solved it as a classification problem.
Hmm.
So to classify the things, and so we have multiple machine learning models which does the classification. So like the clustering and all those things. So I have read some of the things, some of the terminologies over here.
Yes, absolutely. So talking about the traditional collaborative filtering, basically, like you said, we are storing the relation of customer to the product and all the metadata, etc. And then we are like propagating through a single customer and reaching the another end customer, then products, and after that we are like showing the recommendation. So probably we can think it as a brute force method where we are like what we can like if you assume it as a graph data structure, then we are just DFSing through one node and we are trying to reach to like what 1 lakh customers or something like that. So that's
Right.
very expensive. And later like how they are and there's deeper insight like how the traditional method works as well. So there's some formulation like uh, this you can recall from your 12th or 11th grade
Mhm.
physics or mathematics where vectors are involved. And so basically if let me draw some pictures. So basically this is a vector is nothing but some what a length like some fixed value, the amplitude, and then a direction.
Right.
So, and what they are saying that like similarity of these two vectors, basically how this the resultant they are trying to find.
Right.
So, and we know by the mathematics of vectors that if we want to find a resultant, that will be on the same plane and that will be the scalar product, right?
Right. The cosine of the both of the
Right. So
vectors.
that's this part basically. So this wherever it's pointing, it will be the like the common interest of the both the parties.
Right.
So that's how they were traditionally filtering the customers, and that's where it was very expensive. Because like assume the A, there are 10 million A's and 10 million B's, and then into the number of products, so that's n vector, n dimensional vector. So now imagine multiplying those n into n into n. So that's
That many resultants, right?
yeah, right. So that will be really really expensive. And so yeah, like I can see here they have highlighted few what complexities and
Complexities.
yeah. So we go like we know that that's what worst case, and in the worst case m is the number of customers and number of products.
Yeah, so they are considering that the customer vector is extremely sparse, so they are far, far away. Then the algorithm performance tends to be closer to M, O of M plus N. But scanning every customer is approximately O of M, not O of M n, because almost all customer vector contain a small number of items. Okay, so yeah, it like generalizing, because mostly customers are buying less number of items at
Right.
fewer times, and they are very sparse, right?
So it is sorry. Does this thing
I
undoes?
don't do undo, no, no worries.
Oi. Ah. So and now cluster models. So let's read that why it's happening so frequently. Hmm. To
To
understand this
find
why
customers who are similar to user, cluster models divide the customer base into many segments and treat the task as a classification problem. So they are making clusters of the customers, I guess, or the similar items. The algorithm's goal is to assign the user to segment containing the most similar customers. It then uses the purchase and ratings of the customers in the segment to generate recommendations. The segment typically are created using a clustering or other unsupervised learning algorithms, although some applications use manually determined segments using a similarity metric. A clustering algorithm groups the most similar customers together to form a cluster of segments. Because optimal clustering over large data set is impractical, most applications use various forms of greedy cluster generation. These algorithms typically start with an initial set of segments, which often contain one randomly selected customer each. They then repeatedly match customers to the existing segments, usually with some provision for creating new merging existing segments. For very large data sets, especially those with high dimensionally sampling or dimensionality reduction is also necessary. So, so it's talking about the clustering which could be done to
yes.
generate recommendations, and so they are just discussing the methods from which the problem could be solved.
Hmm. So I assume like since the number is very large, here we are talking about 10 millions,
Millions.
right? So whenever these kinds of things happens where we have to like assume like there's very huge data set and we have to derive a what we have to derive an output, but it doesn't have to be what static like the same every time we have like assume there's some function, there's a black box, and when we are passing that huge data set 10 billions of rows, and we don't want each time the row to be perfectly the same as a previous result. So in that case, like we can convert this to a, language model, this what machine learning problem, because then we can implement these all forest what forest
Random
algorithms, and
forest,
yeah,
all those
forest
algorithms,
and
machine learning algorithms.
classification algorithms, etc., etc. So we have like what abstracted out this compute, not abstracted out. We have like just taken out this whole compute from the server to just a language model, which will be definitely faster because it learns and it can get results. Like we have to train that model once, maybe it can take like a week or 2 weeks of time, but after that we'll get the results almost instantaneously. Not we don't have to wait for this of and for each network call, like for each time we want to calculate the recommendation. So that's how like they have been innovative here and founded a solution to like change it to a machine learning problem, right?
Yep.
Mhm. Then okay, so that's some imagery that we are having here.
That's just a recommendation screen they have. So
Yes.
if you will click on the software requirements, your recommendation is the software requirements book. Then there are Star Wars, Discipline, Death March. So this is just, I think, the your recommendation feature homepage using the feature customers can sort recommendation and their own product ratings. Okay, customers who brought items in your shopping cart also bought mathematics, game development. Yeah, so basically, if you are like buying a programming book, then all sorts of books which are related to programming will come to your recommendation, right?
Mhm.
So that's what they're talking about. And and yeah, we can read from here. Cluster model. Cluster model group numerous customers together in a segment, match a user to a segment, and then consider all customers in a segment similar to customers for the purpose of making recommendations. Because these similar customers that the cluster model finds are not the most similar customers, the recommendations they produce are less relevant. It is possible to improve quality by using numerous fine-grained segments, but then online user segment classification becomes almost as expensive as finding similar customers using collaborative filtering. So, collaborative filtering, what they mean actually is, so suppose Aditya Pramanik is liking scissors or pens, and Akhil Singh is liking scissors. So they will be matching on the basis of scissors, and they will recommend me pen as well. So that is what I think they mean by collaborative filtering, and that will not exactly ensure that my recommendation will be good for me. So the recommendation they are providing will not be good for me because they are segmenting customer product both. They are treating that as a one entity, I guess. So that will that will produce irrelevant recommendations. So and they are saying that it can be fine tuned by adding more parameters and more segments, but at the end that will cost them time and compute. So, and also like if you're buying something and the recommendation page is loading and loading, you won't be waiting for any recommendations,
Mm.
right?
Absolutely makes sense. Yeah. Amazon.com uses recommendations as targeted marketing tool in many email campaigns and most of websites pages, including high traffic Amazon.com homepage. Clicking on the recommendation links lead customers to an area where they can filter their recommendations by product line and subject area. Rate their recommended products, rate their previous purchases, and see why items are recommended. Figure 2 shows our shopping cart recommendations, which offers customer product suggestions based on items in their shopping cart. This is similar to impulse items in the supermarket checkout line, but our impulse items are targeted to each customer. Amazon extensively uses recommendation algorithms to personalize its website each customer interest because it's so this basically highlights like whenever we are standing in a queue, the checkout point of an offline store, assuming DMart. So there you can see like the few chocolates or like the chocolates or whatnot, the hairpins and etc. are just they are very close to the checkout point because you are most likely to buy that thing up. So but that is not specific to a customer, that is specific to a whole society, like how uh, m- a larger group of people will willing to buy that item. But here what they Amazon do is they care about the individual customer interest, and then based on their whatever they have in their shopping cart, they recommend further items which the user might be more willing to like add to
But
their yeah, checkout basically. So that's that. And now for again search based
so the search based is also the previous method which they have tried out. They are comparing their current method with, which is item to item collaborative filtering. So search based is, I think, so customer is searching something and then they are making the unions of that, and I think they are providing the recommendations according to that.
yeah.
So
So I think here they are trying to draw a line like we have started with this, right? What?
the collaborative,
Traditional
traditional
collaborative
collaborative
filtering.
filtering.
So here we have issue with the compute. Basically, for one customer, I have to visit tens of millions of customers with tens of millions of products, and so we are limited to like just showing this recommendation in the bottom of the bottom of a single product, right? But now since we have like transformed into a machine learning problem where the results are faster, now we are they have introduced they can introduce various other metadatas like search, how user stays to a stays with a particular product, and rest of the other factors, and then recommend better or recommend on different pages, maybe like we have seen on the checkout page or bottom of the the page they are viewing, or as an ad in the Google search or somewhere. So
Right.
that.
So the search based method is similar to, suppose you are searching Maggie. So if you will search Maggie in the Amazon.com, they have also cracked that Yippee will also come there, ramen will also come there. So if you are adding in ramen, then all the search, the search query results, they will be coming to your recommendation. So that's what they are talking about when they are saying that search based methods. So,
Mm, how it
so
works.
now how it works. So you can directly jump into the algorithm which they have written in the next page. This is the algorithm that they have written.
Sorry. Mm, so I think that's also a brute force
Yep.
algorithm only. Basically, they are for each product catalog, they are looping through, and the customer who has purchased, and then for each item purchased by the customer, record that customer purchased, compare the similarity. So basically, for each item of the catalog, for each customer that we have already seen, they are computing the similarity. So they are basically hitting the model, wants the model to answer this part. So
Right.
again, before we need to like for this was very expensive, and now
Yep.
this they have optimized. So but still we have to look through this much things, but yeah, that's still faster than what we have
They are not just solving for fastness. They're also solving for the correct recommendations as well.
accuracy, yeah, like
Accuracy, right?
and more willingness to buy, like how the actual recommendation is what
More
more
relevant.
relevant to a user or not. So that's that. um, so here we can see the complexity of the algorithm above. Like we can easily compute this m, m cross m, and then again for each m, I have to go through the different items. So that's
Right. And square M.
now. Usability items table the find similar issues purchase ratings aggregates the items and counted most notable items. Competition is very quick. Depending on only the number of items user purchase or rated. This uses dimensionality reduction, sampling and partitioning, all which reduce recommendation quality. Cluster models can perform much of the
Oh,
computation
but
offline, but recommendation quality is relatively low. To improve it, possible to increase the number of segments, but makes online user segment classification expensive. Acha. Search-based models build keyword, category, and author indexes offline, but fail to provide recommendations with interesting, targeted titles. They also scale poorly for customers with numerous purchase ratings. The key to item dynamic is performance that is creates expensive similar items table offline. The algorithms online component looking up similar items for users purchase and rating skills independently of the catalog size of the total number of customers. It's depend only on how many titles the user has purchased or rated. Thus, the algorithm is faster and extremely large. So basically, what they I can draw from this paragraph is that they have like omitted this part, not the n square part, just n cross m part. Basically, they are just sorry. Let me undo it. So basically, they are just focusing on this part from the ML.
Right.
And yeah, so they are just focusing on the products that should be shown to a particular customer.
Mm.
What's that line? And yeah, and rest of the things scales independently. Like it doesn't depend on the number of users or the
Catalog
items
size.
on the catalog. Yes. Now scalability comparison. Okay, so now there's some
Already
talking.
read the scalability comparison that was in the next paragraph. So that was scalability comparison between different kinds of methodologies which we have discussed about traditional collaborative filtering, the search based algorithm, and the search based recommendation system, and the cluster based algorithm system. And they concluded that the item to item collaborative filtering is the most scalable and the relevant recommendations which is currently being used might be. It's paper from 2003, so I'm not very sure that they're still using it or they have just improvised their machine learning models.
Definitely. In fact, yeah, because this also seems very less effective in terms of the what compute and different technologies and set of collaborative tools we have. So
Right. And now the user base, if you talk about user base comparing from 2003 to now, so instead of, a million, they are serving in billions.
billions, absolutely.
So I think that will be really interesting that how they are doing it. So we can, just think it of how could this be done.
Hmm. So what do you suggest? Like, let's have few numbers. White page. So assuming what you said, 8 billion.
No, I'm not talking about 8 billion. I'm talking about just 1 billion. From 10 million to 1 billion only.
1 billion. Okay, so let's suppose there are 1 billion users in total, and now the product catalog. So what do you suggest? What number should we put in for catalog?
Catalog has grown to, so
Hmm.
let's like 50 million, we can target 50 million.
50 million. So that's power 6, and for above that's power 9, right?
Right.
Now, uh, so we want to, like, if one user buys anything, we want to recommend out of this 50 million products, and also like we have to search if a user with similar interest has encountered few other items, so we want those items to be recommended to this user. Let's call them A, and B is a user with common interest. But again, A will have some like past history of purchases or a number of different factors, like it the user A is independent, so they have their own interest. So again, we have to consider the B's interest, we have to consider A's interest, and then we have to search across this 50 million uh, relative nodes. So, what do you suggest? What might be the solution for this in this current situation? What
Okay,
is
so what I can think of first is that first thing first that they have, segregated firstly the products
mm,
based on the regions. So suppose things which are being sold in the USA will not be recommended to me in India, right?
Okay. No, so
So
now this is
so the
partitioned.
yeah, partition, because the 1 million you cannot be, like you cannot do that.
Hmm.
I think like it could be done, but it will be slower. So I think they might have segregated region wise first. Now that region wise thing could be scaled down to very state wise as well, but it does not make sense. So I think it might be country or country.
Country, yeah, or
So let's talk about country wise. So our parameters drastically reduces from 1 billion to it comes to million. So suppose the 1 billion comes to 20 to 30 million, right? And the product category, and then product catalog also decreases
decreases, yeah,
by
60.
50%, I guess. So you can say that 25 million now. Now, on the basis of categories of the items which we are purchasing. So, so and the relatability, like the cosine thing which we have discussed.
Hmm.
So, suppose I am buying any, I so suppose any scientific calculator or something like that, then what thing first comes to your brain is a book related to that, like a problem solving thing, or uh, what
Mathematics or physics or something
mathematic
like
books, etc.
scientific book
So
basically.
yeah, so I think like they have labeled the products basis on the category. So food, studies, and all those things. So it will not be, like relevant to recommend a noodle to a person buying a calculator.
Calculator,
Right.
absolutely.
So I think like they have first categorized the products on the basis of through a lot of metadata and their research. So two things which are running behind is from 2003 we can say that they can forecast the things which people might buy on the basis of the products they have. There are a lot of data, right? So already they have a pre-computed data of things and items around that, and I think like it's both ways. So pre-computing and the post-computing both are working together here. Not just the collaborative item to item collaborative filtering they are seeing now, I guess,
Hmm.
because the catalog has increased very much. They're in large amount of data, I guess. So first labeling of the items and filtering out, or like segmenting and putting them in a cluster, which we were talking, and now they are doing item to item item, no, cluster to
Cluster collaboration. Basically,
collaborative
item to item collaboration on the clusters.
on the cluster, right, right,
Yeah. So basically, we have reduced like this 50 million to somewhat around 1 lakh or something. So
right,
that's
right,
easier, that's quicker, and we can do even what's they saying online, the basically real time processing over that.
right.
So I think yeah, that might be the current scenario, solution to the current scenario, I guess. Right.
Like that I can think of my current understanding of the how might be the product is working. We can deep dive later, or we can, like find a different paper which discusses it in a more, structured manner. It was very layman terms which I have used.
Yeah, yeah. So I think that's that about this paper.
Yeah, it's 2003 paper. Like when we were very small, they were solving for the problem of item to item collaborative filtering so that they can sell more products to the user.
Yeah, the problem was first introduced, might be first introduced at that time.
Right, right.
And in fact, the tools and technologies at the time they might not have allowed to like
No,
think beyond a
right,
certain
right, right. So machine learning was very new at that point. Machine learning started and then it shut down, and then machine learning started growing. And I think the machines were not very much powerful to train the data, and there was not, and there were not, the data which is available right now. So they have very less amount of data. So the more the data grew, they had more, anchor points to create uh, what we can say pre-decisions or decisions before a person is coming. So according to age, according to gender, according to the region, you know,
Graphics,
yep,
etc.
yep, yep. So all these things are come into play now.
Right.
Firstly, they were item to item. Now everything is mattering. Everything is being mattered, right?
So
So,
before,
and the first paper I'm seeing without any Indian author.
right, there might be some references. Sandy writes, it is sales representatives. Hmm, that is there.
That is one why Soham,
Why so? Where?
eighth number. And
Oh,
that 10 number BM Sarwar.
why so?
Um, I don't know that that might be Russian as well, but
Shoham might be Indian or Pakistani.
I know, no worries. I think it was a good paper to understand the problem and different kinds of filtering methods. These are like not useful for now if you are solving any problem now,
Mhm.
but they're good for smaller scales or uh, you have building a new business and you want to suggest things and you have very less amount of items in your hand. And I think this could be a good start from there instead of uh, investing in fancy things.
Right. Mhm. So yeah, so today we discussed about the vector databases, and also we have touched few what parts of like how recommendation would work in the real life, and then few time complexities of the algorithms, and yeah, let's
Y-
call it a stream.
yup. Yes. So we are starting again. So I think like we can target one or two a week, uh, because I don't think daily is possible for now.
Hmm. Yeah, maybe also like we can for daily stuff like I said in the earlier part that we can have few small topics that we can explain it to different levels.
Right, right. We can try that.
But it's
Let's try
obviously
that. It's not a hard and fast rule to
yeah.
do anything. That's the idea. So good night, Aditya. Good night, friends.